In 2025, a team of 28 international scientists published research that stopped the paleontology world in its tracks, not because they found a living megalodon, but because what they found was almost more unsettling. It was evidence that the shark we thought we knew, the one we have been reconstructing, debating, and dramatizing for nearly 2 centuries, was never real to begin with. The megalodon of your imagination is wrong. Significantly, measurably, scientifically wrong. And once you understand what it actually was, the question of whether it could still be out there becomes a great deal more complicated. That question is what this video is about. In October 1666, the Sea of Livorno yielded a catch that would quietly upend centuries of natural history. 2 fishermen, working a French boat, hauled in a shark so large its head alone became the focus of scientific curiosity. The rest of the body was left at sea, impossible to transport, but the head, cleaned with alcohol and wrapped in silk, made its way overland to Florence under the orders of Grand Duke Ferdinando II de' Medici. The Duke, with a taste for marvels and a keen eye for the progress of science, sent the specimen straight to the Danish anatomist Niels Stensen, known to posterity as Steno. Steno received the head in late October. He dissected it in the university's hall, drawing careful illustrations of the jaws and teeth. What caught his attention were the triangular serrated teeth, identical, he realized, to the glossopetrae, or tongue stones, that had been dug from Tuscan limestone hills for generations. These stones, once thought to be the tongues of dragons or petrified lightning, now revealed their true nature under Steno's scalpel. He compared the teeth in the shark's mouth with the fossil stones, noting not just their shape, but their internal structure and mineral composition. In 1667, Steno published his findings in Florence, including a detailed appendix and engraved plates that set out his argument. These tongue stones were fossilized shark teeth. His reasoning was clear. If the teeth in the living shark and the stones from the hills were the same in form and substance, then the stones must be the ancient remnants of creatures like the one before him. For the first time, fossils were anchored to living anatomy, and the sedimentary rocks of Tuscany became a record of vanished seas. Steno's insight gave teeth a new authority as evidence, transforming curiosities into the bedrock of paleontology. In that moment, the story of Megalodon and of every fossil shark shifted from legend to science. In 2019, a team of paleontologists published findings that would overturn a century of assumptions about Megalodon's identity. For decades, textbooks and museum displays had drawn a straight line from the fossilized teeth of this giant predator to the modern great white, Carcharodon carcharias. The logic seemed simple. Triangular, serrated teeth meant a close kinship. But the new study, led by Robert Boesenecker and colleagues, challenged that logic with a rigorous dental character matrix, 38 distinct features measured across more than 100 specimens, and each trait coded and analysed with cladistic precision. The teeth told a different story. Megalodon's serrations, once thought to mirror those of the great white, proved to be wider and less regular, lacking the fine, parallel microserrations seen in Carcharodon. The roots, too, diverged. Megalodons were broad and bilobate, marked by a pronounced basal constriction, not the narrow, compressed roots of its supposed descendant. Even the stratigraphic record refused to cooperate. The last true great whites appear millions of years after the earliest megalodon fossils, breaking the supposed ancestral chain. The 2019 analysis placed Megalodon not within the family of modern lamnids, but firmly within the extinct Otodontidae. The genus name shifted to Otodus, and with it, the entire evolutionary narrative. No longer was Megalodon a supersized great white. It was something older, stranger, and more distantly related than anyone had imagined. The lineage people thought they recognized was, in fact, a case of convergent evolution. Two predators shaped by similar pressures, arriving at similar weapons, but separated by deep time and divergent ancestry. This reclassification did not just shuffle the scientific labels, it demanded a fundamental rethink of Megalodon's anatomy, its ecology, and its place in the ancient seas. Museum halls and movie screens have long cast Megalodon as a swollen juggernaut, an underwater tank built for brute force. But the evidence now tells a different story, one that begins at the microscopic scale and ends with a silhouette that slices rather than bludgeons through the water. Under scanning electron microscopes, the surface of Megalodon teeth reveals coarse bundles of enameloid, their texture less refined than the fine, parallel striations seen in modern great whites. The mineral composition, dominated by fluoroapatite, sets these teeth further apart from their supposed descendants. Each tooth is a fossilized argument against the old model, showing a structure built for shearing, not simply crushing. The vertebrae, too, refuse to cooperate with the myth. CT scans from the Belgian North Sea specimen, catalogued in 2024, present a spine that is broad, but remarkably thin. The centra, the bony discs of the backbone, stretch wide, yet maintain a slender profile, with a length to diameter ratio greater than 2. This is not the architecture of a barrel-chested beast. Instead, it matches the body plan of a predator built for long-distance movement, one that sacrificed bulk for speed and range. The neural arches, where muscle once anchored, are smaller than expected, hinting at a more flexible, less top-heavy frame. Taken together, these details strip away the familiar outline. The Megalodon that emerges from the data is not the overbuilt monster of imagination, but a streamlined hunter, a form more akin to a mako or a lemon shark, scaled up to impossible size. The old reconstructions, with their exaggerated girth and ponderous mass, collapse under the weight of new evidence. What remains is a creature whose true shape was hidden in plain sight, encoded in the minerals of its teeth and the geometry of its spine. The mental picture must be redrawn, not a relic of brute force, but an apex predator engineered by evolution for relentless pursuit across ancient seas. The numbers now entering the scientific record defy ordinary comprehension. In 2025, a Danish-led team set out to answer a question that had haunted paleontology for generations. Just how large could Ottodus Megalodon truly have been? Their approach left no room for guesswork. They assembled the most complete vertebral column ever recovered, a fossil from the Belgian North Sea that spanned over 11 meters long in life. Using high-resolution CT scans, each centrum was measured, digitally reconstructed, and then compared against the living blueprints of modern lamniform sharks. The team's statistical backbone was a Bayesian allometric model, one that did not simply scale up from a single tooth or vertebra, but pooled hundreds of data points from both extinct and living species, each weighted by evolutionary distance and anatomical function. The results forced a reckoning. The posterior distribution curve generated from these simulations did not just nudge the upper bounds of size. It redrew the horizon. The median estimate landed at 24.3 meters in length, with a credible interval that edges into the territory of the blue whale. The corresponding mass was approximately 94 metric tons. For a moment, the familiar scale of ocean life collapses. The largest great white on record barely clears 6 meters. Even the largest predatory fish alive today would be dwarfed by this animal's shadow. No museum diorama, no Hollywood rendering has ever captured the sheer scale implied by these numbers. This is not a matter of artistic license or speculative excess. The volumetric reconstructions, built from the vertebral architecture and muscle attachment sites, show a creature whose length and mass are not just plausible, but demanded by the data. The silhouette that emerges is both sleeker and far larger than any previous model. A predator whose presence would have redefined the structure of ancient seas. The implications are staggering. If such a giant once ruled the oceans, what would it take to sustain it in the world today? The deep ocean is a realm of shadows and unanswered questions. Even now, more than 80% of the seafloor remains unmapped, its trenches and ridges untouched by light or human presence. Within this vast unknown, the idea of a hidden giant refuses to die. In 2017, a tooth surfaced from a sediment core near the Mariana Trench, its enamel still sharp, its serrations undulled by time. Some claimed radiometric dating placed it at just 24,000 years old, a blink in geological terms. The precedent of the giant squid, once dismissed as a sailor's fantasy, now drifts through the abyss as proof that enormous predators can escape notice for centuries. Ocean anomaly researchers point to gaps in Hadal zone sampling and to the sheer scale of unexplored habitat. In a world where the impossible sometimes surfaces, the case for a living Megalodon is built not on fantasy, but on the stubborn persistence of the unknown. Metabolic scaling models draw a stark line through the survival hypothesis. A predator weighing 94 metric tons would require an uninterrupted supply of high-energy prey, hundreds of kilograms each day, just to maintain basic function. Power to mass equations, borrowed from living lamniform sharks, show that even a modest cruising speed would demand an energy budget rivaling the productivity of entire ocean regions. Marine ecologists have tracked global carcass and bycatch records for decades. Across more than 30,000 documented shark strandings and millions of longline hauls, not a single tooth or vertebra matches the scale of Megalodon. Deep sea surveys, logging thousands of hours in the abyss, reveal no silhouettes, no remains, nothing that could be hidden by chance or luck. The fossil record, too, is unyielding. After 3.6 million years ago, Megalodon teeth vanish from every well-dated marine deposit. The evidence, measured and cross-examined, leaves no room for a giant predator lurking in the dark. The legend collapses under the weight of its own biology. Today, every fossil and calculation points to one truth. The Megalodon we imagine never existed. Science rewrites monsters into mysteries, stripping away myth until only reality remains. The ocean's greatest predator is gone, yet its shadow proves how little we truly know about the worlds beneath us. Share your thoughts below.